Our keynote speaker is Associate Professor Michael Valenzuela. He is leader of the Regenerative Neuroscience Group at the Brain and Mind Research Institute at the University of Sydney. Wouldn't it be great going out for dinner and people say, "What do you do?" And you say, "Well, you know, I'm the leader of the Brain and Mind Institute." Associate Professor Michael Valenzuela is one of Australia's leading experts in ageing, Alzheimer's disease and dementia. His background is in psychology, clinical medicine and neuroscience research. The general theme of his group's work is furthering our understanding of competing forces of neuroplasticity and degeneration in the ageing brain and harnessing this knowledge to prevent and treat dementia. Michael believes that dementia is a critical factor in the ageing of our society, and he dedicates a lot of time to communicating healthy brain ideas to the public. In 2011, he released a popular science book in this area called Maintain Your Brain. It's available in ABC Books, and he was part of the Alzheimer's Australia team that developed Brainiac, the world's first iPhone app designed to help users maximise their long-term brain health. So please join me in welcoming Professor Michael Valenzuela.
Well, thank you very much, Gail and Michael, for the opportunity to present this morning. It's certainly a pleasure to be just communicating and talking to a new audience. I'm going to start off by showing you this painting, one of my favourite paintings. If you want to see it, you have to go to Barcelona, to the Picasso Museum. It's called Las Meninas. It's a wonderful painting. So many, I mean, when it was done, it kind of caused so much comment and controversy because of the new ideas that Picasso was presenting here. It's based on the original Las Meninas by Velázquez some 300 years before that. If you want to see this painting, you have to go to Madrid to the Prado. When Picasso was a young man in his teens, he would spend many afternoons going to the Prado and studying the old masters, and Velázquez was his real hero. So when Picasso drew, well, first of all, Velázquez painted himself into the painting, which is really, on the cutting edge at the time. You can see this whole scene draws you in because the main characters are looking at you, the observer. So when Picasso did his version, you can see that Velázquez became his towering figure and he kind of neutralised some of the figures, but the key person there is the princess, right at the heart of the painting. And he did more than 50 different studies of that little princess. And why I start with this painting is that Picasso did this at the ripe old age of 73. And in fact, this part of his life was one of the most productive of his whole career. And so Picasso is one of those real emblematic, figures of how productive you can be towards the later part of your life. And of course, that is in stark contrast at the other end of the spectrum with dementia and how that affects people. So, really what I'm going to be talking about today is the preventative task. How can we better prevent dementia? There's no absolute way, unfortunately, to avoid or prevent dementia, but there's a number of things we can do to minimise that risk and better prevent it at a population level. I'm going to really talk about this concept of cognitive lifestyle, and education is one of the main themes today, is at the heart of this concept of cognitive lifestyle. And what is the impact of one's cognitive lifestyle on dementia, on the risk for cognitive decline in later life, and on the brain? And that's going to be really the heart of the talk. During that, I'll explain this concept in neuroplasticity, which is really key. And then, towards the end, I'm going to be introducing my ideas of how can we harness this knowledge into practice? How can we better, implement it in the community so that, in fact, our risk for dementia goes down, the number of people with dementia is lowered compared to otherwise, and so forth. And then just finally, my own kind of talking points about what can we do, what are the big issues facing this area, just as kind of editorial insertion into the talk. So this is my new scary statistic, which I start a lot of, for example, pitches to funders and policymakers. If we look back a few years ago to the GFC and all the resources and effort that was put into combating that at the time, probably trillions of dollars worldwide. The International Monetary Fund, quoted in The Economist here, made an analysis, and between now and 2050, we'll need to spend about 10 times that amount if we continue to spend, as we do today, on three main age-related issues: health, aged care, and pensions. So if we continue spending on those three main issues as we do today, taking in mind this explosion of the ageing population around the world in developing and developed countries, it's like a rolling GFC every 4 or 5 years. Now, that's not going to happen. We've already tanked out the budgets around the world. So this is an area that's going to undergo incredible stress and change. So what can we do about it? This is some analysis from Professor Henry Brodati's group at the University of New South Wales, which is the latest Australian data. Basically what it shows is that, well, first of all, if we go back, where today, these are all projections of new dementia cases or people newly diagnosed with dementia starting from today, so which is why 2012 we're at 0. So we're starting as if we were a year ago, and the number of new dementia cases all the way to 2050. So status quo, we just keep on doing what we're doing at the moment. There'll be essentially 3 million new diagnosed cases of dementia between now and 2050. At the moment, there are about 300,000 people with dementia. So think of that proportionally and factorial. Now, what the main analysis was, starting in 2020, so in 7 years' time, let's assume we have a strategy in place which all it does is delay the onset of dementia by either 1 year, 2 years, 3 years, 4 years, 5 years. So if we can get a strategy in place that delays onset by 2 years, well, by 2050, that would be 400,000 fewer people that develop dementia. So in other words, more than the whole population with dementia right now. So that's a huge impact by a relatively modest target, right, of delaying dementia by 2 years. And if we aim high, if we delay dementia by 5 years, well, then that's 1 million fewer Australians diagnosed with this issue. So I think that is the preventative tasks that we should be aiming for, and I'm really talking to that for the rest of the talk. Now, in simple terms, and this is the simple terms, the way I guess our group, my group, views dementia, really dementia is a balancing act between two things. One is the disease building up in people's brains, the Alzheimer's pathology, the vascular pathology, and the accompanying loss of brain cells. So that's the disease. On the other hand, is the concept of neuroplasticity. And depending on the balance of those two things, really, I think, influences the outcome, which is whether or not someone experiences dementia, which is loss of cognitive function over time to the point you can't do day-to-day activities anymore. Now, this is a really key point. You can have someone with the same amount of brain disease, but more neuroplastic resources tips the balance, and that individual won't necessarily experience dementia. So if you did a brain scan or you did an autopsy, you may see lots of amyloid and other pathology in their brain, but clinically, personally, at a personal level, they didn't experience the dementia. So in other words, they would have died without knowing that their brain had this disease. And that happens quite often. In fact, 30% of people with significant amounts of Alzheimer's pathology in their brain never have dementia even until they die. And it's one of the key issues in the field is trying to explain that. And what we're understanding more and more is because these people have much more of these neuroplastic resources. So how do we stimulate all of these neuroplastic mechanisms, and what are they? I'm going to elaborate on that. The key thing, which kind of ties into today, is about cognitive lifestyle, which is about learning. I think it's about continuing to learn throughout one's lifetime. That is really what stimulates these neuroplastic resources. And this is kind of a worldwide picture by the group, which kind of looked at all the different risk factors, and they calculated, well, if we reduce that risk factor by 10%, what would be the worldwide impact? What would happen if we reduce that risk factor by 25% worldwide impact? What you can basically see here is that cognitive inactivity, mental laziness, is the worldwide leading risk factor that we can make an impact on. So you can see if we get a 25% reduction in cognitive laziness, mental laziness, that would translate to, say, 1.5 million fewer people with dementia worldwide. So this is a major risk factor that we need to address. And some time ago, I carried out what's called a meta-analysis, which is basically putting a whole bunch of large studies together where there is some kind of controversy in providing an overall number. So each of these little lines is an individual study from around the world. These are large studies, some of them had over 1,000 people. So that overall here, in a snapshot, we're looking at the combined study of about 50,000 people. And we've got a line going up and down. So if a particular line was to the left of this vertical line, that means there was a protective effect of education in that one study. You see this study, it crosses this line, which means there was no effect, positive effect, etc. So it's a mathematical way of combining studies. And basically what it found is that if you're an older person who had more education and less education, well, you're about 50% of the risk of developing dementia later in life. If you had a more complex occupation in your working life, you're about 50% lower risk of dementia. And if you're currently, as an older person, doing more mentally stimulating things, you're also about 50% lower risk of dementia. And no surprise, when you put it all together, there's about 50% lower risk for people to develop dementia in the next 5 to 10 years if you're more mentally active. And that's what I call having an active cognitive lifestyle. So that's been shown now in dozens of large studies around the world. This is some new research that I worked on in collaboration with appropriately Professor Michael Valenzuela in Cambridge, using her very large population study of more than 13,000 people. And we're looking at this simple model where, people usually, before they're alive, with good cognition and death, they usually transfer through different stages. And so, in this model, we assume that someone may start with clear cognition, then transition into some kind of borderline state where they don't quite have dementia, but they're not quite right. And then, I think very importantly, people bounce in between these stages quite often. Then some people go on to develop dementia, and we all die. In statistical terms, all-encompassing final terminal state. So what we applied this very long-term rich data to this model. And what we found is if you have a more active cognitive lifestyle, it has numerous effects, which are really fascinating. One is it reduces your chance of going from clear cognition to borderline kind of state. Similarly, it reduces your chance of going from that arrow should be going to there. It reduces your chances from going from clear cognition to dementia. It increases your chances of going from a borderline state back to normal cognition. And interestingly, it increases your chances, if you're already demented, to passing away earlier. So what this means is that there's a compression of what's called morbidity. So it extends your life years in either the normal cognitive state, and it reduces your life years in a demented state. Now, from my experience, most people, most communities, most families and health departments, that is a win-win situation. Compression of cognitive morbidity. As far as I know, it's the only intervention which does that. For example, other things which are very important, like physical exercise, it extends both things. So you have more time in a cognitive clear state, but also more time demented. And so there is implications there, very important implications. So compression of cognitive morbidity is a key issue. As part of my PhD so many years ago, we developed a tool which is called the Lifetime of Experiences Questionnaire. And basically, it's a 15-minute questionnaire where it really gives a snapshot of what you've been doing with your brain for your whole life. So cognitive lifestyle. It's a way of measuring cognitive lifestyle, and it looks at three main domains of education and young adulthood, occupational activities in midlife, and leisure and learning activities in late life. It has a lifespan perspective. So it asks about all of these things throughout your whole life. And I mean, we learned so many things through this simple questionnaire. First of all, we know that people transition between cognitive lifestyle, types or profiles more commonly than just staying the same. So if we just look at the people that were in the bottom third of this questionnaire in young adulthood, and then we track them in midlife and we track them in late life. So only half of those people that started off as low were low in midlife and low in late life. So in other words, the other half did some other kind of combination. So what we've learned is that people are transitioning through cognitive lifestyle activities levels quite often. And if we drill down at the individual kind of activity level, again, there's a lot of complexity. People change throughout the lifespan, and also on some issues, there's differences between men and women. So just for example, so as we come up here, it means you're doing activity less often. So here, females are practicing a musical instrument much more often in young adulthood, and then both men and women are dropping off that activity as they progress, but men in general doing it less frequently. So it's just showing you there's real complexity in these kind of activities. This one I think is a real worry, which is the frequency of reading for more than 20 minutes in a session. So most people in young adulthood agree that they were doing that. So in this case, this scale is number of days in between doing that. So in young adulthood, it's only a few days in between doing that. In midlife, maybe a week in between doing that. But in late life, people were going a whole month between reading something for more than 20 minutes. I don't think there's really an excuse for that. So we need to be, really emphasising the importance to continue all those reading habits. Now, one of my PhD students used this data and tried to look what in the brain may be, connected to these lifestyle habits. So he used the same LEQ data, and we had nice imaging data from more than 150 people, and he really drilled down on what could be causing this effect. And first of all, what he found was that midlife activities were associated specifically with protection in the hippocampus, so that sausage-shaped structure in that direction to the hippocampus. And using this technique, we really saw, this is, in my experience, a pretty remarkable result because it was just so concentrated on the hippocampus. The hippocampus is the memory centre of the brain, and it's the part of the brain first affected by Alzheimer's disease. So when you start getting Alzheimer's disease, it starts to shrink. People with a richer midlife LEQ score had a fatter, larger hippocampus. And we drilled out further onto that. What he discovered was that it was the number of people that you had supervised or been in charge of or having to manage during your working life, which was specifically connected to the protection of the hippocampus. And there seemed to be a threshold effect. If you had supervised, been in charge of, having responsibility for 10 or more people, whether you're a man or a woman, it led to a protected, fatter, healthier hippocampus. And as I mentioned, the hippocampus is kind of Alzheimer's central, and for protecting the hippocampus, it kind of makes sense that we're protecting people from Alzheimer's. And furthermore, he showed that if we looked at longitudinal imaging data, so imaging data acquired over a number of years, if you'd never been in charge of anyone, the hippocampus shrunk by that amount, so about 10% over a 3-year period. And if you had been in charge of 10 or more people, you see it was pretty stable. So this is a continuing benefit to this key brain structure through an activity with we were doing 10, 20 years ago. So it has this ongoing thing. How can that be? And this is just nice, pretty, I've got to show this nice, pretty movie showing, basically showing those red, so that whole structure of the hippocampus, you can kind of see where it is in the brain. Those red areas are the specific areas that are being protected from shrinkage. And that's a very similar pattern to the most high-risk areas in Alzheimer's disease. So it does really seem to be something important in this activity of supervising, being in charge of other people. And what it is about that kind of activity that's so important, we don't know. There's lots of theories, and maybe if I've got time at the end, I can talk about that. So this is really an example of neuroplasticity. Neuroplasticity being a series of changes in the brain that occur in response to complex mental activity. I think the simplest example is a study done a few years ago where they got university students to learn to juggle over a couple of weeks, did these brain scans, and found that these particular areas, the hotspots in the brain, actually got bigger during the juggling training. So this is percent change, so they increased by about 3-4% bigger through juggling. These are the areas activated by the juggling training procedure, and you can see that after you stop training, it starts to go back towards zero. So it's like a muscle. Right? If you exercise the muscle, it becomes stronger, it becomes bigger, metabolic changes, resistant to damage and injury. So the analogy, I think, works at a big picture scale for the brain. Now, of course, you don't just go directly from juggling to a bigger brain. There is a whole cascade of things happening to get to that point, and a whole cascade of things that continue to happen later. So this is really what neuroplasticity is. It's about changes happening at a molecular scale very quickly, cellular changes happening, in a scale of weeks, and then these large macroscopic levels. This is the scale that we can see with imaging happen really over the period of months. So that's what neuroplasticity is. So now, how do we use this science and what we've learned into something that works? So this is my brain training lab situated at the Montefiore home in Randwick. And you can see these are people going to a brain gym. So they're sitting in front of the computer and doing mental exercises with us, with an expert, and they're getting trained on different exercises and problems. And this clinical trial, which is now finished, was basically designed so people were randomised into training or an active control, and we did several tests during the training and then after the training, and some people also undertook brain imaging. So these are just examples of some different exercises, where here you've got to work your way through a maze. Here you get a command, click on the right above square, and the fastest way to click that square is important. Here is to decipher that word, etc., etc. So it's really a model, it's kind of like cross-training for the brain. You're training all the different major cognitive domains. And what we found was that on our outcome measure, it worked. So our outcome measure was overall cognitive ability. And what we see on the y-axis is an effect size, which just means how well it worked. And if you just focus on the global cognition, that was the main outcome measure. You can see 3 weeks of training, you see pretty impressive effect. And then continuing up to 3 months of training, that effect starts to plateau off. So in economic terms, there was a bit of a law of diminishing returns there, but at some point the brain starts to plateau off in terms of its effects. Then 3 weeks after stopping training, there's a pretty fast decline. The 3 months after stopping training, there is some residual effect. So this is really key information for us to start designing the most effective cognitive training interventions and therapies to start rolling out in the community. And I'll just quickly go through this, what my student Annette Mumpet showed is that in conjunction with that, some specific areas of the brain got bigger, and the amount that those bits of the brain enlarged were correlated or connected to the therapeutic effect. And also using some fancy functional imaging to look at the brain's activity levels. He showed that connectivity of the hippocampus, and remember a key brain structure related to memory, connectivity of that hippocampus actually also changed in response to training, and perhaps was related to therapeutic response. So we're starting to, I guess, generate some key information about, first of all, links between an active cognitive lifestyle and reduced dementia risk. Understanding that those links seem to be related to neuroplasticity and some specific mechanisms that occur in the hippocampus, and that we can translate this into an effective intervention based on supervised, computer-based cognitive training. So what we don't have yet is a large study showing that by doing this intervention, we can actually prevent dementia. All we've shown so far is that we can improve older people's cognitive abilities, specifically those older people with a dementia risk factor. So that's a good thing. But we haven't gone that next step to show that we can prevent dementia. And the reason being is that we need incredibly large clinical trials to show this. And I think it's time to start planning and designing and carrying out this trial. Because if we look at overall population health, probably the biggest strides in the last 20 years have been in cardiology. And that's been based on these very large trials, based in multiple countries with tens of thousands of people. And that's how they showed that, taking 5 milligrams of aspirin after a heart attack improves mortality. That's how they showed that, cholesterol in someone improves morbidity 10 years later. Those kind of trials. I think that's where we're at now, and we need to start designing and planning and lobbying for the funding to do these clinical trials. It's something that's kind of my main job at the moment, is trying to get a partnership model together so that we can carry out these trials. The other kind of talking point, I think very relevant to today's meeting, is about rethinking retirement. Most people understand that to financially plan for retirement. I hope what my talk has convinced you that you have to cognitively plan, mentally plan for your retirement, because as I've shown, what you do during your working life has a material impact on your brain in later life, and that continues to be the case. This is some really fascinating economic data. There's a journal of, I think, economic policy. What they showed was, on the x-axis, this is the employment rate for someone, say 55 years of age, compared to someone 45 years of age. So, if you were at 0, it would mean that you had the same employment rate as a 55-year-old as you had a 45-year-old. So, going this way means less and less employment in an older person relative to a middle-aged person. And on the y-axis, it's a similar but memory performance. So the closer you are to 0, it means that as a 55-year-old, you have memory as similar to a 45-year-old. And going that way means it's worse. So you can see this poor outlier France, which people retire militantly at 55. Those older people, their memory is much worse than the average French 45-year-old. Whereas on the other end, in the States, where you just keep working until you die, it seems to have a positive effect on memory compared to the average 45-year-old Yank. So average 45-year-old Yank is not that proficient, or there is an effect. And what's interesting is that, in general, the countries line up. So there may be a connection between the participation rate of seniors and cognitive performance of seniors. And I tried to look up where Australia would fit in here, and I can only find not quite satisfactory data, but we kind of fit in there. We've probably changed. I heard Wayne Swan this morning saying that the participation rate of seniors now is the best in the world. I don't know if that's true. Maybe Michael can tell me. So hopefully we're going up on the x-axis, which hopefully will mean that memory performance is better. Really the key issue here is that what we do in retirement mentally, I think, has an important, link to our memory abilities, our risk for dementia, and the neuroplasticity happening in the brain. And it's not just very focused clinical interventions like the computerized cognitive training example. It's really about participating in the community and learning. I really admire this study from the United States called the Experience Cause. And what they showed is that if you get older Americans, they were mainly Afro-Americans with so many risk factors for dementia, and get them to volunteer in their local primary school, so to help teachers with running a class, to help manage the kids going to and fro. We had two fundamental outcomes. First of all, the cognitive health of those older people improved, and you could see that on cognitive tests and also using imaging. And two, the educational outcomes of the kids also improved. So this is a win-win situation, and there's another kind of community-based program that I want to explore with my colleagues around Australia. This is another kind of concept which is doing as much as we can to encourage older people to actually get back to formal education, something Gail mentioned this morning. So in Tasmania, in collaboration with James Vickers, we're running a very innovative study where we're actually looking at the 10-year outcomes of older people where we're allowing them to go to university for free and study a course. And I don't think why that should just be public policy. Now there's this key difference between awareness and behavioural change. So Michael mentioned I was part of the team that introduced Brainiac, a fantastic device for making people aware of the different risk factors and encourage them to change their behaviour. So as an awareness tool, I think it's been fantastic, but whether that actually leads to behavioural change, people changing their lifestyle, doing more cognitive activity, I'm not sure about. I think you need something much more to realise behavioural change. That's kind of the goal at the end of the rainbow, is behavioural change, changing population patterns. And if we look at the most successful public health result in Australia, which is this lowering smoking rates over time, there's really been multiple strategies and multiple initiatives which has got us there. And Professor Simon Chapman, who was, I guess, the leader Australia-wide academically on this whole initiative, I asked him what he thought was the number one key ingredients to the success, and he said, well, there's two. He said legislation and taxation. So it's not just about telling people, you do more exercise, or you need to go out and learn more, or you need to do this. At some point, the message is saturated, people know it, but they don't do it. And there's very complex reasons why they don't do it, but if you change the legislative and taxation environment to encourage that behaviour, I think that's when you start to see actual population level change. So for example, if there is no charge for an older person to go back to university and study a course, that is a policy legislatively kind of environment which then drives that behavioural change. And I think that's where we need to go. And that's why I'm calling upon groups like the seniors group here to start thinking about a national dementia prevention plan. Something I'm talking about Alzheimer's Australia and other groups, because we need a kind of multifactorial strategic plan in place which includes government, includes advocacy groups, includes obviously the community, so that we can see some kind of curve like that in the next 20 years when it comes to dementia. Thank you so much for the invitation. If you want to learn more, buy my book, and I'm happy to take questions if time allows. Thank you.
I'm just wondering if there's any chance of reversing dementia through cognitive training. And the other one that I've got is what effect do children have on stimulating or reverse the opposite to having children? What does that do?
Two good questions. So first of all, can we reverse dementia? Does cognitive training help in that regard? Unfortunately, most of the studies of cognitive training in people already with dementia have really shown very, very limited results. Maybe a little bit of a positive result in terms of non-cognitive outcomes, so in terms of their ability to settle, their ability not to become agitated, things like that, even their mood, their mental health status. But I think it's really too late when someone already has dementia, because on average you've lost 10 million brain cells by then. So the whole other half of my group is working on some very blue sky kind of strategies to try and replace those brain cells. But that's a decade away from clinical trial. So the main message really is prevention is so much more important at this stage. The other question, what about kids? Does kids improve our cognitive lifestyle? I haven't been able to find any evidence to that effect. So it's not because that might not be the case. I don't think people have looked at the question, does someone who's grown up with this whole series of exposures, are they better off compared to matched people who have had kids? People just haven't asked that question, particularly women who score poorly on my scale because they haven't had a career during their working life, that they were raising a family. It seems like those women are just they're still at very high risk for dementia and have these poor hippocampal plasticity outcomes. So I don't think it's necessarily effective. Obviously it's very challenging, stimulating, but also stressful endeavour. So I don't really know what the answer is yet.
Well, there's lots of questions because we do in fact have 10 minutes, so please think up your questions. I think the next one is here, and then there, and then over there.
Thank you. The question may not be all that relevant, but I'll ask it. You showed that supervising other people helps the long-term outcome. In supervising other people, I imagine there's a huge amount of interaction that a person has to cope with, and constant decision making as well. So how does that then, how it may relate to autism?
How may it relate to autism? Well, if you have a full-blown version of autism, you're not likely to get into those kind of top managerial positions, so you won't really be benefiting from that level of exposure. I guess the broad answer to the question, what is it about supervising others which seems to have these long-term positive implications for the brain and dementia? Again, we don't know. One thing that it's not related to stress. So 10, 15 years ago, there was this idea, if you were the alpha male of some monkey tribe, that you had lower stress than the subordinate monkeys, because the subordinate monkeys had no control over their destiny and the alpha male just does whatever they want. So now it's kind of been turned on its head with more, I guess, precise measurements of stress in these kind of experiments, showing the fact that the alpha male is the most stressed of the whole pack, and it's these subordinates that enjoy just having a very narrow, constrained repertoire of things they can do. So it's not that if you're managing people, you have this, ideally stress-free life. What it does seem to be connected with, and you kind of brought it up, is the amount of social interactions that you're having. So high-level managers, as a 60 or 70-year-old, are having more social contacts currently than if you were not an high-level manager. So there seems to be this flow-on effect that you sort of get trained in interacting with people, and you probably seek it out as an older person. And that's undeniably positive for your brain. The other hypothesis, which I'm interested in, is the fact if you are in charge of other people, you need to be constant. It's almost like a little model in your brain as to what they should be doing today, this week, this month, this year, and so forth. So you're continually updating and forecasting, for the people under your supervision. And that cognitive ability, which is called prospective memory, thinking ahead about something and remembering about it, is very much hippocampally integral to the hippocampus. You need a strong, healthy hippocampus to be able to remember to do things in the future. So I think, it's a very complex, rich activity, and I'd really like to think about how we can use that maybe as an intervention, maybe as a way of treating people.
Have you any experience in dealing with people who maybe play computer games and also listen to music? Does that have an effect on dementia?
Yeah, so there are some pieces of research out there which have just looked at game playing versus kind of browsing on a computer. And I don't think there's a clear result there yet. It may be positive, but there's also an opportunity cost. If you're just at home playing a game, it may actually be better for your brain if you're out volunteering, in a community setting. The other part of the question was music. So playing and practicing music was part of this questionnaire that we developed. We haven't yet found a specific link between music playing and either brain outcomes or dementia outcomes. But I just don't think we have the large enough sample size. It's another thing we're doing is we're collaborating with groups around the world so we have this kind of information on thousands of people that can actually identify those specific activities that are most important.
Thank you. It's very interesting to hear all this research, and it's great that it's being done. And I would like to just question you as to, is there any link or research that is actually looking at mild autism, the autistic spectrum disorder in early childhood, and then later early onset for cognitive impairment? And also, have the canvas, are you looking at the connection between autism and...
So another question about kind of the autistic spectrum. Not an area that I'm specifically involved with. There's kind of a general truism that the more brain-related illnesses that someone has over their lifespan, it contributes to a slightly higher risk of dementia later in life. So whether that be a brain injury early in life or epilepsy during adulthood or mild autistic spectrum, these kind of issues. It does contribute, but there's no necessary link. I guess the one exception is people with Down syndrome have a very high risk of developing dementia earlier and also the amyloid pathology. So I'm not aware of the specific links between mild autistic syndrome and dementia later in life, because it's not really my area, I'm sorry.
About 7 or 8 years ago, when Dr. Doyle was out here, I actually bought his book, Rewiring the Brain, which I found which was a lot to do with what you've been speaking about, the plasticity, and also Dr. Susan Cabot's book, which I found also very interesting. But how comes a lot of doctors that don't really want to know about it, they don't understand or even when you speak to them, they haven't even heard about it. And I found that quite, quite interesting.
So you need to educate them.
They don't like being told it, and they don't like to ask questions. I like to ask questions, and they don't like answering them. But it was very interesting.
Keep fighting the good fight.
Yeah. But it was really interesting, his book about that.
Yeah, I think you're talking about Norman Doidge's The Brain That Changes Itself.
Yeah, on the brain that changes that, yeah, that's right. And very, very interesting, and what you're doing, the work is brilliant.
Thank you.
Thank you. There was another one, just behind that gentleman, there was another one in that same row. I was along there. There we are. She's got it in there. Someone there in there.
Good morning. While you're speaking, I'm just thinking that it's Hazel Hawke's memorial service today, and I'm sure she was, had a very active brain and worked for many years in a charitable organisations, and I'm just thinking what you're saying seems to be a little bit contradictory to her lifestyle.
That's a good question. In fact, Sue Peters-Hawke asked me the same question, how about my mum? I hope I emphasised at the beginning that really what I'm talking about, population level trends, and you can't pinpoint an individual and say because they've done X, Y and Z, that means they're not going to get dementia. Because it's a balancing act, as I mentioned, between the amount of pathology in someone's brain, and genes does at least contribute to that. So someone may have a high genetic predisposition to developing that disease. And on the other side, the neuroplasticity, no doubt Hazel Hawke had an incredibly high cognitive lifestyle, very active, yet she succumbed to the disease. That's unfortunately the nature of the illness, that we can't be specific at the individual level, but I think the evidence is fairly strong and even overwhelming, but at population level, these are the kind of links that we see.
We're just about to run out of time. I already got two people, so we'll set out them very quickly. This gentleman here and there was another lady here, I think.
Okay, my question is that it relates to the last part of your discussion, to say that we can help if we're active now and we participate in formal education at this stage. We can make our life better or extend our life in that respect. My question comes to is that if it's an online application of some qualification, or if it's an actual physical going to a university, whatever it might be, is the social interaction as important as the actual course itself, or are they the same?
I think more and more, if you were just to compare, if you did the same course at home online, there's the same course somewhere, with other people, I think the social, real thing is better. It's not to say the thing at home is of no value, but there's a very large body of evidence now showing that social interaction per se has positive impacts on the brain and lowers dementias.
And the last question?
I'll call it out, it's short. Has there been any links with diet and dementia?
So the question has been, any links between diet and dementia? I really recommend my book about this whole chapter. To cut the whole chapter down to a few lines, it's really about generic links between diet and brain health. So there is no specific diet that specifically helps you protect you from dementia. But there's general health things which everyone kind of already knows, particularly eating fish or fish alternatives in your diet, because it's proven to reduce your risk for heart attack and heart disease. And there's a very strong link between heart disease and vascular disease in the brain. Vascular disease in the brain is the number 2 contributor to dementia. So you can see a pathway there. So it's really about general health being important, but there's no magic anti-dementia diet.
Thank you very much. Very good. Calls to help your brain.